Hello and welcome to CCNA Subnetting video number 1. My name is Wendell Odom. I'm the author of the ICND-1 and ICND-2 official exam certification guides from Cisco Press, and this video is the first of 8 different videos that are available with these books. This first video shows an example of how to find the subnet number given an IP address in mask, specifically for IP address 128.200.100.100 with mask 255.255.224.0. This video has both a tactical objective as well as a strategic objective. Tactically speaking, the goal of this video is to help you understand how to use a particular process to find an IP address's resident subnet. Every IP address sits inside some subnet, and we call that the resident subnet. Now, the strategic objective is to help you prepare for answering subnetting questions on the CCNA exams, in particular that you be able to answer those questions quickly and with confidence. Now, if you watch this video and understand the process, that's not enough. You need to practice. In fact, you need to practice until the process becomes very natural. We don't want you to try to memorize the particular steps shown here, but we want you to be able to look at a problem, and by having practiced it enough, you can look at it and say, oh, the resident subnet for that IP address is whatever it is. The specific process described in this video is taken from the Cisco Press exam certification guides. Now, this process shows how to find the resident subnet even though a difficult subnet mask is used and with using no binary math. Now, when I say difficult mask, I mean the mask has an octet whose value is neither a 255 nor a 0, and for most people that means that finding the resident subnet is not very intuitive. So this video will use the same process as explained in those books. And by the way, this process is summarized in a CD-only appendix in those books. And that appendix refers to this process as reference page 5C, or for short, RP-5C. So if you see a reference to RP-5C, it's just a reference to what's listed in the books. Also, just for reference, note that the books also show a much simpler process for finding the resident subnet when a nice easy mask is used. In other words, a mask that's all 255s and zeros. Before taking a look at the process, let's take a closer look at what I mean by resident subnet. Every IP address assigned to a host when subnetting is used is inside a single particular subnet. So the resident subnet is the subnet number of the subnet in which an IP address resides or an IP address is a part of. For instance, here in the figure we have PC1, and it's been assigned an IP address of 128.200.100.100, and it's got a mask of /19 or 255.255.224.0. Now the question is, what is the subnet number in which this IP address resides? As it turns out, the subnet number is 128.200.96.0 with that same /19 mask. Now, why do we care? Well, one reason you might care is that router R1 that's connected to that subnet is going to end up adding a route to that connected subnet to R1's routing table. Here we see a representation of R1's routing table that lists that subnet as a connected route off the Fast Ethernet 00 interface off R1. If other routers existed in the picture, R1 would then advertise a route for that same subnet to the other routers that exist. Now, another fact you might want to know is, what's the range of IP addresses that can be used inside that subnet? For instance, if you added another PC to this subnet, what would be a reasonable IP address to choose that would be a legal IP address? So, to answer that particular question, we'll use a related process that we call RP-6C, which answers the question of what is the range of IP addresses in a particular subnet. The screen now shows a copy of the 4-step process that will be demonstrated by this video. Now, one of the reasons this video exists is to show you how to use the process, so rather than just read the process off to you, next let's take a look at how to use the process to find the resident subnet. To begin, you can use an empty table that leaves a convenient place to put the subnet mask, IP address, and resulting resident subnet number. Now here at step 1, we simply copy the mask and IP address into the table. Then at step 2, we draw a rectangle around the interesting octet. Now the interesting octet is identified by the subnet mask octet, whose value is not a 255 nor a 0. In this case, it's the third octet with mask value 224. Next, at step 3, we'll identify the values in the 3 uninteresting octets. First of all, at step 3A, we'll look for any octets to the left of the rectangle and simply copy the IP address's value down into the subnet number. Here we see we'll start with 128.200 in the first 2 octets. Then for any octets to the right of the rectangle, we'll simply write down a 0. So now we've got 128.200.something.0, and the fourth step will then fill in the something in the third octet. Now at first glance the process may seem a bit odd, but it always does give the correct answer, and it doesn't require any binary math. The first part of step 4 starts with the calculation of the magic number. The magic number is calculated as 256 minus the mask's value in the interesting octet, which is 224 in this case. So in this case our magic number is 256 minus 224, or 32. Now there's nothing particularly magical about it, it's just a word I use to describe this particular number. Now, as it turns out, the resident subnet number in the interesting octet is a multiple of this magic number. So at step 4b, we're going to calculate all the multiples of the magic number. We start with 0 and calculate all the way up through 256. Now the subnet number's value in that third octet is going to be one of those numbers, but which one? So at step 4c, we compare the IP address, not the mask, but the IP address's value in that interesting octet to the list. Now that value is 100 in this example. We see that 100 is closest to the multiples of the magic number that are 96 and 128. And we simply pick the smaller of the two. So in this case, we pick 96, so the subnet number is going to be 128.200.96.0. When this video began, I told you that the tactical objective of this video is to help you learn a particular process for finding the resident subnet. Well, now that you've seen one example of its use, now take a couple of examples and try to work those right now. Here on the screen you should see two additional examples with different IP addresses and masks. Once you work these two problems, you can watch two additional videos which show you how to get the answer, again using this same process. Now at that point the process should become a lot clearer to you if it hasn't already, so then you should just keep practicing the process until it becomes natural for you. In fact, you should shoot for being able to do this process and find the resident subnet for any type of question like this within about 10 to 15 seconds. At the same time, then you might want to also study the other process, the one that I reference as RP-6C in the exam certification guides, that show you how to find the range of addresses in each subnet. Hi, and welcome to CCNA's subnetting video number 2. This is the second of 8 videos that are included with the ICND1 and ICND2 official exam certification guides from Cisco Press. This video shows a second of 3 examples of how to find the subnet number for a given IP address and mask. In particular, this video shows how to find the resident subnet for IP address 10.99.88.77 with mask 255.255.248.0. This video has the same tactical and strategic objective as does the first video. In particular, the tactical objective is to help you learn how to use a particular process, as shown in the books, to find the resident subnet for a given IP address and mask. Strategically, this video and the others are designed to help you learn how to subnet quickly and with confidence so you'll be ready for the exams. At the end of this, we'll point you to more practice so you can get to the point where the process is automatic. What you see on the screen now is a summary of the process that will be demonstrated in this video. I'm not going to go through every step at this point. The point of the video is to show an example of its use. It's just listed here so that you can move back in the video to review this process for easy reference. So let's take a look at the example for this video. You start with a convenient place to write down the numbers, and you start at step 1 by simply recording the subnet mask and IP address in the first 2 rows of a table. Then you find the interesting octet, which is the octet in which the mask has a non-255 or non-zero value, which of course is the third octet in this case, and you draw a rectangle around it. Then at step 3, you find 3 of the 4 octets of the subnet number. At step 3a, for any octets fully to the left of the rectangle, you simply copy the IP address's value in those octets down to the row for the subnet number. Then at step 3b, for any octets fully to the right of the rectangle, you simply write down a 0. Step 4 finds the value of the subnet number in this remaining interesting octet. The process says to first find the magic number. Now the magic number is 256 minus the mask's value in the interesting octet, which of course is 248 in this case. So the magic number is 256 minus 248, or 8. Then in step 4b, you calculate all the integer multiples of the magic number, starting with 0. And because they won't all fit on the screen, I put some of the more interesting values here. Now to find which of these multiples is the value of the subnet number in this remaining octet, we compare the IP address's value in that octet to the list. And we want to pick the number that's closest to 88 in this case, but not bigger than 88. Well, it's pretty clear that 88 is actually one of the numbers in the list, so 88 is closest to itself and is not bigger than itself. So the subnet number's value in this octet is 88, giving us a subnet number of 10.99.88.0. The best way to get good at this process and to get fast at this process is to practice. So if you'd like, go ahead and try the problem you see there on the screen now and find the subnet number, and then you can check your work with the process using Subnetting Video 3. To continue your practice, you can go to the ICND 1 or ICND 2 exam certification guides, which each have an identical Appendix D, which provides you some more practice. Hello and welcome to CCNA Subnetting Video 3. This is the third of 8 subnetting videos that come with the ICND 1 and ICND 2 official exam certification guides from Cisco Press. This is the third video that shows how to find the subnet number given an IP address and a mask. This video shows how to find the subnet number for IP address 192.168.1.150 with mask 255.255.255.240. This video has the same tactical and strategic objective as does the first video. In particular, the tactical objective is to help you learn how to use a particular process, as shown in the books, to find the resident subnet for a given IP address and mask. Strategically, this video and the others are designed to help you learn how to subnet quickly and with confidence so you'll be ready for the exams. At the end of this, we'll point you to more practice so you can get to the point where the process is automatic. What you see on the screen now is a summary of the process that will be demonstrated in this video. I'm not going to go through every step at this point. The point of the video is to show an example of its use. It's just listed here so that you can move back in the video to review this process for easy reference. So now let's take a look at this specific example. The first 3 steps finds the value of the subnet number for 3 of the 4 octets. Here at step 1, we simply copy the subnet mask and IP address into a convenient table for reference. Then in step 2, we identify the interesting octet by finding the subnet mask's octet whose value is neither a 255 nor a 0, which in this case it's the 4th octet because of the mask value of 240 in that octet. Then at step 3, we do 2 parts. At step 3a, we look for any octets fully to the left of the rectangle and copy the subnet number's value in those octets down to the subnet number. At step 3b, we look at any octets fully to the right of the rectangle, which of course in this case there are none because the 4th octet is the interesting octet. There are no octets to the right of that. There's no 5th octet. So there's nothing to do here at step 3b. So at this point we know that the subnet number begins with 192.168.1. Now if it's already intuitive to you that the subnet number would begin with 192.168.1, then you can ignore those first 3 steps and go ahead and figure out the 3 obvious octets. Regardless, we've got 1 remaining octet to figure out. So at step 4, we start by calculating the magic number. We do that by subtracting 240, which is the interesting octet of the mask, from 256, which gives us a magic number of 16 in this case. Then you calculate all the integer multiples of 16, starting at 0. Here we show part of that list for convenience. And then you compare the IP address's value in the interesting octet to the list. In this case, we're comparing 150 to the list, and 150 is between 144 and 160 as you see here. But we want the value that's closest to 150 but not larger than it, so obviously 144 is the closer but not larger value. So the value is 144 and the subnet number is 192.168.1.144. Now that you've seen several examples of how to use this process, it's important to practice until you get good at the process and you're not thinking about each particular step. Of course, the ICND 1 and ICND 2 books, Appendix D, have more example practice problems along with explanations of how to find the answers to those problems using this shortcut process. At that point, you'll probably want to move on to watch videos 4, 5, and 6, which show how to find the subnet broadcast address and range of valid addresses in each subnet.